Hey everyone, welcome to The Explainer. I'm honestly so thrilled you're tuning in today because, well, we're going to do something incredibly empowering. We're going to decode what I like to call the hidden matrix of Cambridge IGCSE and O-level computer science exams. Like, have you ever walked out of an exam hall feeling just perfectly confident, only to get your paper back and see drop marks on topics you swore you knew inside and out? Yeah, it's the worst. If that's you, this explainer is literally exactly what you need. Today we're using binary addition and overflow as our main example to figure out exactly what examiners are secretly looking for. We aren't just memorizing facts here, we're hunting for the patterns behind those facts. Let's get into it.
Okay, look at this quote right here. Students often think they know a topic until they try to express it in that third layer. This just hits the nail on the head, doesn't it? It perfectly captures that trap of false confidence. I mean, you study the definitions, you recognize the vocab words on the page, and you feel totally ready. But here's the reality check. Recognizing a familiar term is a completely different ballgame from building a high-scoring answer while a clock is ticking down. This mysterious third layer we're talking about, that's where the magic actually happens, and it's exactly where we're focusing all our energy today.
So, here's our roadmap for decoding these exams. First, we'll tackle the vocabulary trap. Then, we'll break down the 3 layers of mastery, followed by looking at description versus explanation. After that, we're unlocking the power of context, and finally, we'll wrap up with an awesome 4-question self-check. Let's just dive right in.
Section 1. The vocabulary trap, moving beyond isolated definitions.
Right, so one of the absolute most common mistakes students make is treating the whole syllabus like it's just this massive, disconnected vocabulary list. And hey, I get it, it's super tempting to just rely on flashcards. But memorizing terminology, it just isn't enough. You have to remember that these topics are meant to solve actual digital problems. Let's take our example of binary addition and overflow. A really solid understanding doesn't start with just knowing the math rules. It starts by linking that math to a practical consequence. Like, what problem does an overflow error actually cause for a user or a whole system? When you understand the why and the real-world reason for a concept, you retain it so much better than if you just tried to blindly memorize a textbook definition.
Moving on to Section 2, 3 layers of mastery, from everyday words to exam excellence.
Now this is a super powerful framework. It totally shifts your brain from just knowing a fun fact to truly mastering it. And this mastery happens in 3 distinct steps. Step 1 is everyday language. Ask yourself, could you explain binary overflow to, say, your grandmother, using a really simple concept like pouring too much water into a tiny glass? Okay, then step 2 is technical vocabulary. This is where you layer in the actual subject terms, like 8-bit registers. But here is the kicker. Step 3 is the exam explanation. This means shaping that technical idea into a tightly structured response that's actually going to score maximum marks while you're stressing under time pressure. You literally have to push yourself past step 2 to get to step 3 if you want those top grades.
Section 3. Description versus explanation. The critical exam distinction.
So how do we reliably hit that third step of mastery? Well, we've got to understand this critical distinction right here. Because honestly, it is where thousands of students lose easy marks every single year. A description just tells you what the device or process is. It sounds safe, sure, but it's really shallow. An explanation, on the other hand, tells the examiner how it works and exactly why it matters. And guess what? Examiners almost always expect both. Think about it. If you jump right into explaining without naming the concept first, your answer just sounds kind of confused. But if you only describe it, you are leaving all the deepest, highest value marks just sitting on the table. No way we're doing that.
A fantastic way to nail those explanations is to completely understand the theoretical boundaries between similar concepts. Look at these classic examples on screen: memory versus storage, data versus information, validation versus verification. In computer science, your reasoning becomes like infinitely stronger the second you clearly define where one idea ends and the other begins. Imagine a question asks about validation. You spot a familiar word, but you accidentally write down an explanation for verification. Boom, you score absolute 0. Training your brain to spot these contrasts quickly is absolutely crucial. It basically controls the success of your entire answer.
All right, Section 4, the power of context, seeing the matrix of the question.
Here's the deal. Generic cookie-cutter responses in computer science exams almost never gain full marks. Why? Because a concept never actually exists in a vacuum. To really conquer context, you need a highly disciplined exam path. First step, identify the question's demand. What is it literally asking you to do? Second, classify the correct concept. Third, explain the sequence step by step in total logic. And fourth, and this is the absolute crucial one, connect your explanation straight back to the specific context provided in the prompt. Just brain-dumping facts in a random order won't cut it. This precise four-step sequence is what produces that clear, structured reasoning that examiners practically beg for.
So, the big takeaway here is this. Your answer has got to stay locked inside the specific environment the examiner sets for you. If they ask about an overflow error in, say, a banking system or a school management tool or some automated robotics factory, you have to frame your answer around that specific world. Don't just leave the idea floating out there in generic abstraction. Showing real-world transfer really matters because it proves to the person grading your paper that you haven't just memorized a book. It shows you actually understand how the technology functions out there in the real world.
And that brings us to the pitfalls. These are the most common traps you'll see. We're talking vague wording, completely missing steps in a logical sequence, or just flat out ignoring that provided context we literally just talked about. Or, oh, how about this classic? Stating an advantage but not giving any reason for it. Another really common one is fixating on a single keyword and going off on a tangent describing a related idea that isn't actually being assessed. This is exactly why doing error-aware preparation, where you're actively looking at common mistakes right alongside the correct facts, is vastly superior to just passively reading over your notes.
Section 5. The 4-question self-check. Your ultimate revision blueprint.
Okay, listen up, because before you move on from studying any topic, I want you to ask yourself these 4 questions out loud. It guarantees your exam ready. Question 1. What is it? Honestly, can you paraphrase the core mechanism accurately? If you're relying entirely on the exact memorized wording from your textbook and you totally stumble when you're asked to use your own words, you are not ready. You've got to understand the deeper process.
Question 2. How does it work? Remember, clarity of sequence is a huge deal. So many computer science topics are process-based, right? So when you explain how something works, you absolutely must avoid jumping forwards and backwards in time. Explain the core mechanism first, take it step by step, and then, and only then, state the final consequence.
Question 3. Where is it used? This one tests your adaptability. So, can you take your brilliant explanation of binary addition and suddenly apply it to a retail website? What about an industrial network or a communication service? If you can easily shift the context around in your mind like that, your knowledge is truly secure. It means you're ready for literally whatever weird scenario the examiner decides to throw your way.
And finally, question 4. Why is it better or worse than an alternative in that specific situation? High-scoring answers almost always require evaluating choices and justifying your decisions. You need to be able to weigh up an advantage or a disadvantage completely logically while keeping it rooted firmly in the scenario they gave you. Seriously, if you can answer these 4 prompts aloud smoothly, you have officially mastered the topic. Full stop.
So I want to leave you with this final kind of provocative thought. When you sit down for your very next revision cycle, or when you finally step into that exam hall, what are you going to write? Is your next answer just going to be a safe, shallow, totally simple description, or are you going to actively apply this 4-step self-check, decode the matrix of the question, and comprehensively explain the reality of the system? The choice and those top marks are entirely in your hands. Thank you so much for joining me on this explainer. Now go out there and absolutely master that 3rd layer.